In this tutorial, we'll learn how to use the Distributed Dictionary Coding plugin for the Butter text analysis software. What this plugin does is it implements the distributed dictionary representation method that's described in this 2017 paper by Justin Garton and his colleagues. You can think of this method kind of like a fuzzy dictionary method. If you're familiar with something like latent semantic analysis, for example, this is conceptually similar to latent semantic similarity, although rather than matching the similarity between two documents, for example, what we do is we provide 2 or 3 seed words, and then we measure how similar each document is to our clusters of seed words. I'm not going to go into too much detail about the specifics of this method because I think that the best place to look really is this paper where the method is described, but hopefully we'll be able to get a sense of the basics of how you would use this method in the midst of this tutorial. Now what we'll do to start is we'll use a corpus of TED Talks that we have. And these are just transcripts of different TED Talks that I've collected over the years. And we're going to use the distributed dictionary representation method to do some stuff with those transcripts. Now, in order to use this method, you need some model of semantic space. So commonly right now today, people might be using a fast text model by Facebook, a Word2Vec model, one of those types of models. And I won't go into the details of how to do this. You can train a Word2Vec model within Butter using the Word2Vec plugin. You can also find lots of models. Some of the classic ones are glove models that are trained on Wikipedia. These are all over the place online, and you can find them and download them very easily. But you will need some type of pre-trained model in order to use this dictionary. In order to use the distributed dictionary method. Now, which model you should use is going to depend on the nature of your seed words, the nature of the text that you're going to be analyzing, and there's no tried and true way to recommend a specific model for whatever your research project is or research question. So instead, I recommend dig into the literature a little bit, maybe ask one of the people who came up with the DDR method. You can leave a comment on this video if you really want to ask. And you can get some recommendations and get a sense of maybe the best approach for your particular use case. You can also just try different pre-trained models and see how your results vary across different iterations. Now let's go ahead and actually look at what this process looks like within Butter. So the first thing we'll want to do is load up our text files. So we'll just point this plugin to our TED Talk transcripts. We can see that this distributed dictionary coding plugin needs tokens, so we'll go ahead and tokenize our texts. So we take the strings, we tokenize them, now we can give them to the DDR plugin. And when we go to the settings for this plugin, you can see a few things going on here. By default, it has this word list on the left that comes directly from the publication here by Justin Garton. And these are designed to be the different domains from moral foundations theory. And we'll come back to this in just a moment. First thing that we want to do, generally speaking, is choose our pre-trained model. So I'm going to go ahead and point it to this glove file here. And we can see, based on some quick heuristics, it understands that each word is represented by a 300 dimension vector. It doesn't know how big the vocabulary is, but that's okay. Everything is working as expected right now. Now let's say we want to measure how similar each text is to a specific concept, like happiness. We might come up with a few seed words like happy, glad, and wonderful. Now let's say we want to see how similar TED Talks are to another cluster of words, perhaps science. So we'll have a cluster of words that are science, maybe technology, and let's say explore. Now we have two different clusters of words here. What this plugin is going to do is it's going to go to our pre-trained model and get the average vector for each cluster of words. So we're going to have a happiness cluster. That is the average of these three words. We'll also have a science cluster. That is the average of these three words. And sometimes you can use more words, sometimes you can use less words, and the outcomes that you'll get are going to be somewhat sensitive to the specific words that you pick. So you want to pick words that are highly diagnostic or highly representative of a single concept, a single kind of area in a semantic space. So we'll just leave it at this for now. What we're going to do is we're going to go through each TED Talk and measure the semantic similarity of each TED Talk to this happiness word cluster and to this science word cluster. And we'll go ahead and save our outputs here. We'll call it just DDR. Now, depending on your file, we'll go ahead and start this up. It can take a little bit of time to load up that model into memory for this plugin to run. Once this initial process finishes, where it's loading up that whole trained model file, it'll usually go fairly quickly depending on the size of your texts. And this model here is roughly about a gigabyte or so of text. And so it should finish loading fairly shortly, and then it'll start going through each of the transcripts in our data set. Now you'll want to know that the word lists that we added to this plugin here, these are things that must be within our trained model. So if we made up a word and added it to our word list, if it's not represented in the model, it'll just be ignored. Now what this also means is that generally speaking, you can't be using bigrams or trigrams or anything like that. They'll usually be single words that are being captured by your pre-trained model, and that means that you'll have to have single words in your word lists for the dictionary coding plugin here. Also, I'll note that this plugin is designed specifically for the word vectors and the distributed models that we find in the, we'll say, mid-2010s or so. So you can take a pre-trained latent semantic analysis model, a word2vec model, a LexVec model. These all work totally fine within this plugin here. Some of the newer models like Elmo and BERT, these are a lot more complicated, and we don't have a method implemented to do those types of models yet for this plugin here. Now we see that this is finished running. Let's go ahead and look at our results. Now really what we're doing with this plugin is we're calculating the cosine similarity, the cosine angle between each of these word clusters and the average meaning, the average vector of each of our TED Talks. And so these scores here that we see for each of our word clusters, really these are cosine similarity scores. You can also think about these as being somewhat similar to a Pearson correlation. The math is very similar, although there's a couple of important differences there. And we can see that there's pretty good variation here. Some of these texts are probably much more happy than others. We can use this as kind of a proxy for a sentiment analysis task, for example. And we can see that some of these TED Talks are probably also much more science-oriented, we'll say, than others. So we can check this too. Let's look for texts that score very high in similarity to our word cluster here. And this one, we don't even need to go to the transcript. We can see that the title of it is How We Can Use Space Technology to Improve Life on Earth. This scores kind of positively and very science-y relative to all of the other texts. Now if we go to the other end, we can see, for example, the Texas score low, similarity to the Science Technology Explorer word cluster, are things like musical performances, dances, magic moves, so things that are much more in line with, let's say, artistic endeavors. So this method does seem to be working pretty well. And then of course you can take these scores here and use them in any other type of model you would typically apply it to. So if you want to model the relationship between, say, how positive each of the TED Talks were in data such as viewership or ratings or something like that, you could do that with these scores. Now, some other more recent work would use these types of scores to measure things like gender bias in different types of text by measuring the similarity of each TED Talk to word clusters such as he, she, man, woman, things like that. Words that have a clear gender connotation to them. And then you can correlate those scores with other outcomes of interest. And you can do that as well with the distributed dictionary coding plugin. And that's it. That's how you use the distributed dictionary coding plugin for Butter.